Hello everybody. In this short video, I'm going to talk more about how to manage different data sets in a predictive analytics or data mining project. And presumably we're talking about a simple classification problem, binary classification. Previously, there's a video that talked about conceptually how to manage different data sets, and I will provide a link here. Let's go. As you can see here, this video focuses on the hands-on strategy of managing the different data sets. While you may not be able to download this Jupyter notebook, the content and the demonstration in this video should be self-explanatory. And then using this as a resource, you should be able to apply a similar or the same strategy on your course project in your future projects. So essentially, we assume that you will use a train test split mechanism for detecting overfitting. We assume that you will not use the cross-validation mechanism. After you have understood your project problem and you have downloaded the dataset, you're reading the data and perform some high-level understanding of the overall data. This is all the data that you have, which includes information about the target variable. This is what we call the overall data or the training data. And in that process, if you discover some high-level data issues, such as incorrect column labels, go ahead and fix them on the entire data set. And next, as I talked about in the earlier video, I would suggest that you go ahead and perform train test split right away. As a result, you get the X and Y data sets. Depending on what models that you will decide to train, the number of Y datasets could vary. And as I advocate in this course, evaluate the quality of the split by using hypothesis testing right after the split. And then, based off of the train dataset, remember you get both train and test datasets. This train dataset is not the same as the training data, that is the overall, everything included. Here, the training data set is different from the test set, which you are familiar by now. Perform more exploratory data analysis on the training set only, and in the process, form a strategy of pre-processing the data. This would typically include rescaling of dataset, one-hot encoding, sometimes involving logarithm transformation and sometimes also involving missing data imputation. But the latter two topics are not covered in this course. After the strategy is formed, go ahead and pre-process the training dataset by using transformers and pipelines that we talked about in the course. Fit those transformer objects on the training set. After that, do some sanity check on the pre-processed training set, and then go ahead and use those fitted transformer objects to pre-process the test set. Remember, you should not fit or refit again the transformers on the test set. You only use the fitted transformers to transform the test set. After that, do some more sanity checks, and then be sure to convert them into NumPy arrays. And then you go ahead and do the modeling and model evaluation. If you have found your best model and you are satisfied with its performance on the test set, then you are ready to use that trained model, the best model, to do scoring. Earlier, you have read in the score dataset. You will perform some high-level understanding of the score data just to make sure there's no high-level data issues, just like the overall data. And if no issues, then you will use a similar strategy that you use to preprocess the test set here to preprocess the score set. Do not fit transformers again on the score set, and understand that in the case of score set, there is no target variable there. Once preprocessed, you can use that best model to score and then obtain the scored values. This might be a likelihood or a probability estimate and or a classification outcome. The classified outcome of the score cases, and then follow other guidelines from the course to prepare and submit your final submission dataset for the score. Now, if you would like to include cross-validation along with training time split, here is a view of another alternative strategy. In this case, most of the steps about preprocessing are the same. What changes are the steps that are related to modeling and model evaluation. And even if it looks like it's little changed, it is quite a lot of change in terms of the modeling strategies and evaluation strategies. So these changes would be a video of another topic. For now, we are going to focus on the main strategy. So for this demonstration, I have simulated a dataset. So let's take a quick look at the datasets. First, import the packages, and then read in the datasets. The dimensions of the two datasets. The training dataset should have more records than the score set, and the training dataset also has one more column than the score column. Guess what is the additional column in the all dataset? You're right, it is the target variable or the target column. Remember, the score dataset does not have the target column, and that is exactly the purpose of scoring, to estimate or predict the target value or the target label, verifying that the target variable y is not included in the score data, but it is included in the all data. Keep going. Some high-level understanding of the all training dataset. There are 8 columns, including the target column. Keep in mind that this dataset does not have an ID column. In many other projects and datasets, there will be an ID column. There is the target variable. In fact, it is a binary. It's just recorded as numeric, 0 or 1. There are 3 object type variables. Potentially they are categorical, indicated by the name. And there are 4 interval or continuous variables. And more surface level summary of the variables. For all the numeric type variables, let's look at their distributions, statistics. For y variable, the minimum is 0, maximum is 1. The standard deviation is 0.5. The mean is close to 0.5, indicating there are roughly half zeros and half ones. For the other interval variables, their distribution vary, but they all look very normal. Of course, these variables would need to go through preprocessing to be ready for modeling. Recall that there are 3 categorical variables. And here we are going to take a look at the categories or the discrete labels of the 3 categorical variables. Each of them has 3 discrete labels, and here are the frequencies. Since the dataset does not present any serious issues on the surface, there is no need to fix any issues. keep going, I will go relatively faster. Separate the x and y, and then perform the training test. Take a look at the dimensions to make sure everything goes right. You know what to do with evaluating the quality of split. You will do that. You know how to conduct deeper EDA to understand the training set, particularly to understand the variables and correlations and distributions and whatnot. Now let's get started with pre-processing the training dataset. The strategy that you use to pre-process the Y dataset depends on the models that you will use, and I will skip here. But for the input datasets, typically you can follow the standard procedure that we talked about by using the transformers. So for the categorical variable, we will use one-hot encoder. For interval variables, we will use range normalization or min-max normalization. And finally, put them together into a transformer and transform them, and then conduct some sanity check. Confirm that you have the same number of pre-processed columns as you would expect. Recall that we have in total 7 input variables. We end up with 0 to 9, which is 10 variables. So 3 additional variables. Where did they come from? Scrolling back to the list of variables, we know that they are not going to be the target variable in the pre-processed X dataset. So from 1 to 7, in the original dataset, 7 input columns originally. We know that the additional columns could be coming from the categorical variables after conducting the one-hot encoding. For each of the categorical variables, we know that there are 3 discrete labels, and we also know that the one-hot encoding will discard one of the labels. So for the 3 categorical variables, each we will have 1 additional column as produced by the one-hot encoding. As a result, we have 3 additional pre-processed columns. So we have 10 columns in total. Also confirm that the minimum values are all 0 and maximum are all 1. This is because the one-hot encoded binary variables all have values 0 and 1, including the first 6 columns. And then beginning this column, the 4 columns are min-max scaled numeric or interval variables. So this looks great. Then I'm ready to go ahead and use the fitted transformer to transform the test set, and then do some sanity check as well. Observe that we have the same number of variables or columns in the pre-processed test set. Confirm that since the first 6 columns are binary variables, they should have minimum value of 0 and maximum value of 1, and there isn't any value in between. But for the interval variables, I talked about in the class that even though it's min-max or range normalization, the values should be between 0 and 1. There's no guarantee that there occasionally will not be some values that exceed the boundary of these variables detected or learned from the training set. So for the test sets, you can reasonably expect that the minimum value will be different from 0 slightly, and the maximum value might be slightly different from 1. And all of these look normal. So everything's good. We proceed with, finally, the last step of pre-processing is to convert them back to NumPy arrays, ready for modeling. And then you do the modeling, you know what to do, model evaluations, and assume you have a model to be used for scoring, we enter the scoring phase. Earlier we read in the score dataset. Let's do some high-level checking. On a high level, everything looks good. Keep in mind that the score dataset does not have the target variable, so it's one fewer columns. The original distributions of the interval variables look similar to the original dataset. There's no surface problem, so there's no need to fix any surface issues of the score dataset. And for preprocessing, let us use the trained transformer to transform, not fit, but only transform the score dataset and become the preprocessed dataset. Do some sanity check. Again, we observe for the first 6 columns, the minimum and maximum values conform to expectation. For the last 4 columns, the minimum are all different from 0 but not too far from 0, and the maximum value are not exactly but not far from 1. Oh, one more thing. Do not forget to conform the score dataset into the NumPy arrays. Here you go. And for scoring, you will use xscore instead of xscore processed. Alright, once you finish scoring, you will follow the guideline posted in the course materials to prepare the final submission dataset for scored dataset, and then you're ready to submit as part of your submissions for the final project. Alright, that's all. Congratulations on finishing the process. Hope this helps. See you later.